Yeah. I guess I'll just use the. Thanks, Kate. Yeah, I'll just use the Black Ops camera. I guess. Hopefully, it'll still work fine. Okay, so I want to look at something like 30 because it's all letters. They're at least favorite.
Yeah.
Or should we do? Let's do 28 first, actually. Well, these are the trickiest ones. I figured we'd go over one or two examples of these where it's all symbols. So 28. Is that Julia again? Julia, do you not know how to set the alarm? Yes, he was like, oh, I'm sorry, my alarm went off.
I'm technologically challenged.
Yeah, that's okay. You'll get there. You'll get there. Okay, so 28. Marco's he's got a little bit left in him. So this basically is a question saying, can you derive a general relationship between like the quantities involved? If you've got a platform of height h, you got a cannonball pointed straight up or a cannon pointed straight up. It's going to fire out of the cannon with some velocity v, and we're going to answer two questions. Mass is m, of course. What's the other quantity that's going to come into play here? The other symbol, g. So I'll just put g. I'll put g kind of over here. So our final formula is going to involve this. Maybe not every single symbol, because maybe a certain symbol drops out. There's kind of a hint on C. You guys can probably guess which of these symbols is probably not going to show up in the final answer. The mass. Yeah. Spoiler alert. Right, Julia? Okay, the spoiler alert. I put it after the spoiler, though. That's not how you should do it. Okay, so this thing shoots up in the air and then it comes down. Okay. So the first question is, how high will it go? Okay. So what should we call this quantity? Maybe H max, something like that. And we're going to solve for H max and see how does H max depend on H, M, and V. So the technique is pretty much always the same here. Is you write the total energy before, and then you set it equal to the total energy after, and that's called conservation of energy. So you go, how much energy was there right as the ball left the? By the way, you can set it up kind of like this. Initial kinetic plus initial potential is equal to final kinetic plus final potential. Does that make sense? Writing that the way I've written that? So total energy at some earlier point in time is equal to the total energy at some later point in time. So initially, then I've got 1/2 mv squared plus mgh. We're really careful to use the right h. It's that h. Equals. Now, when we say final, that's final sort of, it's all relative, right? For this first setup, this is going to be the final moment, right? Then later on, we'll change our perspective and say this is the final moment. Does that make sense? So anyway, up here then, so how much kinetic energy is there up there? 0 plus mg h max. Cool beans? So, algebra time. What's the trick here? What should we do? Let's divide by m first. Divide everything by m. Divide him by m, divide him by m, divide him by m, divide him by m. All the m's drop out. That's nice. Isn't. And then divide everything by g, right? So divide that by g. Is everyone okay with me going straight to this? That divided by G would be that. That's maybe a result you recall. That's the result if you do the calculation of, if you just set a 1/2 mv squared equal to an mgh, just like a ball launched from ground level, this is the max height term. Then this divided by G. So hopefully this answer makes really good intuitive sense. If not, that is maybe a problem. It means you're missing something that's going on here, because this is the answer to how high would a ball go if you shot it out of a cannon straight up at speed v. And then this is just, well, you started off at some height h, so it just ends up getting added on basically. Cool beans? Okay, now the next answer is not quite as simple. Let's see if this blue marker has any life in it. So now we're going to figure out about what happens down here. Okay. Same calculation, but this time it's 1/2 mv squared plus mgh. Again, that's the starting energy. How much energy he had right here. What will I write here for the final energy if we're talking about this moment in time? How much potential energy does he have right there? None. So it's going to be 1/2 m, something like v final squared plus nothing. HMU if there are questions. No? You sure? Positive? Okay, divide everything by m. What next? Multiply everything by 2. Right? So multiply this by 2, you just get v squared plus 2gh. And then one last step. Go in. Okay, your final answer. So you square root this. It's kind of a weird expression. You guys maybe recall the square root of 2gh thing. That is if you just drop a ball off a building, how fast is that ball going at the bottom of the building? Square root of 2gh, where h is the height of the building. But if you shoot the ball up or down, actually, if you think about it, notice, I mean, direction doesn't really matter here, but you get this weird v squared added on inside the radical. It's kind of weird. That's kind of strange, isn't it? All right. Let's do one more. Then we can have a little bit of 20 minutes of just work time, so you guys knock out some questions. Let's just jump forward to like. Let's do 32. So I hope my intent with this question will connect with your thinky winkies over there. Because it is not just a random question. It says a cannonball is shot straight up from ground level with an initial velocity of 28 meters per second. And I'm telling you in advance, it will reach a maximum height of 40 meters. So maybe you just take my word for that. You can confirm that if you'd like. You can calculate that. So this question says, if you shoot a cannonball up at 28 meters per second, it will reach a max height of 40 meters. How high would the cannonball be when it was going half of its initial speed? What is the perhaps incorrect intuitive answer? What's the layperson's answer to that question? They'd say 20, right? They'd say, oh, if you're going half as fast, then you probably made it halfway to your eventual max height, right? Does that make sense? So we're going to find out that that's actually not the case. So think about, do you think it'll be higher than 20 or lower than 20? Before we move on, are there any questions on what the question is, how it's phrased, or like what it's asking?
Would it be 30?
Could be 30. Why 30?
Talk about this relationship with terms of the velocity. It's like either on free souls or so maybe it's just like a full off of its one of those is a full of its height. I don't know if that makes any sense.
I think I get where you're coming from. I don't know. You can maybe make the explanation a little bit clearer, but so you're saying 30. I think that's a reasonable answer. And I get what you're saying, where you're talking about how, say, if you double V, it quadruples the energy. So cutting it in half, there's some factor of 4 there. So that's where you're getting the 3/4. Yeah, I get what you're saying. So, okay. So hey, real quick, this isn't necessary for the question. If you're a credulous person, then you just say, oh, I believe you. But let's say you weren't. 1/2 mv squared equals mg. Let's say you were solving for the max height. This is the calculation, right? So Mr. Calculator, the m's would drop out, and I'd have 28 squared divided by 2 divided by 9.8. And indeed, hope I didn't confuse anyone, right? I was just confirming that the premise of the question is correct. Is that if you shoot something up at 28 meters per second, the math works out that it happens to be a 40 meter max height. But the question's asking, well, okay, what's the velocity? Oh, what's the height? So if the initial velocity is 28 meters per second, what is the height when it's traveling 14 meters per second? So the calculation should be pretty straightforward, right? Write the total energy here. So you don't have to do this for every question, guys, unless you find it helpful. If you take some college physics class, they might make you write this every time, I'm not sure. Initial energy is equal to final energy. So the initial energy would be 1/2 mv squared plus how much potential energy? None. How about up here? You'd have 1/2 mv squared plus mgh. H is what we're solving for, this guy right here. That's the mystery. What drops out of the whole equation? Mass. And so here, I think is where we see what Winslow's talking about. If you didn't see it already, this number is 4 times bigger than this number. So when you subtract them, what you have left over is 3/4 as big a number as you had before. So there's your 3/4. So anyway, see if you go 28 squared divided by 2 minus 14 squared divided by 2. This number here would be 294. That makes sense? This minus this would be 294. And then you have to divide by g. Divide by 9.8. And it turns out to be 30. Okay, so 30 meters. So well done, Winslow, you got it. In the subsequent questions here, you're going to be asked to like derive. Basically, this is it because it's not obvious that okay, maybe it just happened to be it was 40, then it's 30. Is it always true that is it always 3/4? If you generally ask this question, if you say, oh, say I shoot a projectile out at 100 meters per second, how fast is it going when it reaches half of its max height? Is it going to be 75? Like, do you know that for sure? So that's question 34 is asking that question. So it's the same setup. You set up the exact same way, but you just use a V instead of a number. Okay. All right. That's all the talkies I have for you today. You got 20 minutes to just knock out some questions. Tomorrow I'm going to start on some slightly more complicated ones.